in problems 13 through 18, you'll notice they all have denominators that, first of all, the fraction won't simplify like they did up above, and these are not perfect roots. So we have to do, to simplify it, we have to do what's called rationalizing the denominator. We have to multiply by something so that this is a perfect root, and we can take the cubed root of whatever the denominator is. So before you get started, what you might want to do when you're dealing with cubed roots is, again, list all the cubes. So 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125. And if you had to keep going, you could try to figure out what they were. But these are just 2 to the third, 3 to the third, and you can use your calculator to get these, 4 to the third, 5 to the third. So I'm looking at this list, and now instead of breaking it up, I'm looking at what number could I multiply 25 by to get to one of these numbers. Well, I see 125. Now if you aren't sure what that is, use your calculator. Take 125 divided by 25. It's 5. So if I multiply this by the cubed root of 5 in the denominator, I'm going to get the cubed root of 125. When I take 25 times 5, I get 125. So that's why I picked that one, is I had to pick something that I can multiply this number by so that I get one of these numbers in my list, that these are all perfect cubes. So now in the numerator, the cubed root of 4 times 5 is 20. So that's kind of what we learned up above in number 7 through 12. We could just multiply straight across as long as they're the same root. And down here, 25 times 5 is 125. Now, why did we pick that? Because now I can simplify that. Now the cubed root of 125, and again, if you aren't sure, you can always do math, cubed root of 125, just to double check, and it is 5. So the cubed root of 125 is 5. So I write this as the cubed root of 20 over 5. Okay, so I just had to multiply across cubed root of 20, but in the denominator now, once I multiplied, now I can simplify that radical. All right, so number 14 is force. And again, 4 divided by 9 doesn't come out evenly, doesn't reduce, so my only option is to rationalize the denominator. Now, if you want to, you can think of it as the 4th root of 4 over the 4th root of 9. Like if you don't like it all under one radical, just realize it really is just the 4th root of the numerator and 4th root of the denominator. So again, 9 doesn't come out nicely, but I have to think of perfect force. So let's write our force. 2 to the 4th power. 2 times 2 times 2 times 2 is 16. Well, I can't multiply 9 by anything to get 16. 3 to the 4th power. 3 times 3 times 3 times 3 is 81. Again, if you want to use your calculator, all I'm really doing is taking 2 raised to the 4th. That's the first one, 16. And then I did 3 raised to the 4th, and 4 raised to the 4th. So if you need to find your list, you just can use your calculator to come up with what that list is. Once I get to 81, I realize that's the one I'm looking for, because I can take 9 and multiply it by 9 to get to 81. So you're always looking at what can I multiply this by to get to one of those perfect roots. So I'm going to multiply by the 4th root of 9 over the 4th root of 9. Kind of running into this over here, but I'm multiplying by the 4th root of 9 over the 4th root of 9. So in the numerator, I have the 4th root of 9 times 4 is 36. In the denominator, I have the 4th root of 9 times the 4th root of 9. That's going to give me the 4th root of 81. And again, because 81 is on my list of perfect force, I know it is a perfect fourth. 3 times 3 times 3 times 3 gives me 81. So I have the 4th root of 36 over 3. Okay, so I've rationalized my denominator. And I do the same thing with 15. Again, 15 is the perfect cubes because I'm taking the cubed root. So again, if you think of 2 to the third, 3 to the third, 4 to the third, I'm looking for one of these that I can multiply by to get one of these, and obviously 8 would be the quickest one. I could multiply by 16 to get to 64, but I might as well take the smallest one. So I'm going to multiply by the cubed root of 2 over the cubed root of 2. So I need to take 27 times 2, and I get 54. So I have the cubed root of 54 over the cubed root of 8. And again, the cubed root of 8 I can simplify to 2. Now, the other thing you really should be looking for with these is, can I simplify this? Now, when you look at that, you have to ask yourself, is there any perfect cube that I could take out of 54? And so if I do cubes, I could say 2 to the third is 8. Well, actually, I have it up here we can look at. 2 to the third is 8, 27, 64. 27 goes into 54. And so really, up here, I could have taken the cubed root of 27 right away and realized the cubed root of 27 was just 3. And I didn't really notice it when I first looked at the problem, but now I see that down here, when I go to simplify, I can break this up into the cubed root of 27 and the cubed root of 2. So I took this cubed root of 54 and broke it up into 27 times 2, because the cubed root of 27 is 3. So I have 3 cubed root 2 over 2. So if you missed it up here, which would have been a lot easier if I would have realized right away that instead of writing it like this, I could have said the cubed root of 27, which is 3, over the cubed root of 4, I would have had my 3 already there. But I didn't notice it right away, so that's fine. I still use my properties of radicals, but once I got to here, I realized I had to reduce that into the cubed root of 27 and the cubed root of 2. Okay, but that should be our final answer then. Okay, then on the back is just multiplying by conjugates. So when you have, I think these are probably easier. When you have two terms, so they're separated, there's a plus or a minus sign in your denominator, then you have to rationalize by multiplying by the conjugate. Conjugate is just these same two numbers, but the different signs. So if there's a minus sign there, the conjugate will have a plus. If there's a plus sign there, the conjugate will have a minus. Everything else stays the same. So I'm going to multiply this one by 5 plus the square root of 3. That is the conjugate. So remember, we're multiplying that whole binomial, those two terms. This is a binomial, so we have to make sure that we're distributing properly. So here we have to take 7 times 5, 35, and we have to take 7 times square root of 3. So 7 square root 3. That's the numerator, distributing the 7. In the denominator, you have to distribute the 5, first of all. 5 times 5. 5 times square root of 3. And now we have to distribute the negative 1 times the square root of 3. So I'm going to get negative 5 square root 3. And negative square root of 3 times the square root of 3 would be negative square root of 9. When I multiply square root of 3 times square root of 3, I get square root of 9. Now, because they're conjugates, these will always drop out, those two middle terms. That's why we use that conjugate to rationalize. They will always drop out. So if you don't want to write those down, you don't have to. So in the numerator, I have 35 plus 7 radical 3. In the denominator, I have 25 minus, the square root of 9 is 3. So 25 minus 3 is 22. And there's my answer. Now you do need to look to see, is there anything that goes into 35, into the 7, and to 22, so we could reduce it, and we can't. So it is fine the way it is. So all we did is we multiplied by the conjugate, distributed the 7 on top, distributed the 5 and the negative radical 3. The middle terms will always drop out. I'm left with this numerator over 25 minus 3. All right, so let's do the same thing with 17. So with 17, we're going to multiply by square root of 2 minus square root of 7. And square root of 2 minus square root of 7. Again, these are binomials that we have to distribute. So distribute the 6. I'm going to get 6 square root of 2 minus 6 square root of 7. In the denominator, I'm going to take square root of 2 times the square root of 2. So I get the square root of 4. Again, the middle terms drop out. I would get the square root of 14 and negative square root of 14, so they're going to drop out. I won't even write those down. But then the last terms, I take square root of 7 times the negative square root of 7. I get negative square root of 49. So now I have 6 square root of 2 minus 6 square root of 7 over, I have a 2 minus 7. 2 minus 7 is negative 5. And there's my answer. So I do think these are easier. And then the last one, I'm going to multiply by square root of 15 plus the square root of 3. And square root of 15 plus the square root of 3. And again, we have to distribute. So with this one, when I take square root of 2 times the square root of 15, I get the square root of 30. They're both under the square root, so I put them together. Plus, square root of 2 times the square root of 3 is the square root of 6. So again, just notice that they're different than what we did over here because this was not under a square root, so I have to write it as 6 square root 3. Here, these are both under a square root, so that's why I got the square root of 30 and the square root of 6. In the denominator, square root of 15 times the square root of 15. If you aren't sure what that is, you could do it on your calculator. 15 squared is 225. That's going to end up being 15 when I'm done, so if you knew that right away, you wouldn't even have to multiply that out. Middle terms, again, square root of 45 and negative square root of 45 will drop out, and then I get minus the square root of 9. So I have the square root of 30 plus the square root of 6 in the numerator. In the denominator, this is 15, square root of 225. 15 minus 3 is 12. And there's my answer to that one. So I think those last three are probably a little bit easier than the first three.